chapter on memory. The study of memory will look at some of the following questions. How do we process and store information? Are there different types of memory? How do we retrieve memories? And why do we forget? Memory is an information processing system very much like a computer. It is a set of processes used to encode, store, and retrieve information over different periods of time. And if you look at your OpenStax textbook, Chapter 8, you will see an illustration of those three basic processes: encoding, storage, and retrieval. Encoding involves the input of information into the memory system. Storage is the retention of the encoded information, and that is the fact that it is held in a particular system. Retrieval is the process of getting the information out of memory and back into awareness. And as you will learn as we move along, these very, very basic processes are essential for the normal functioning of memory. Let's begin with encoding. When the brain receives information from the environment, it labels and codes it. It also organizes it with other similar information and connects new concepts to existing concepts. We have learned over the years that encoding occurs through two types of basic memory processes. One is automatic, and that is the encoding of details like time, space, frequency, and the meaning of words, and it's usually done without conscious awareness. For example, remembering when you last studied, or rather simply, when's the last time you picked up your OpenStax college textbook. Now we contrast that with effortful processing, which is the encoding of details that takes time and effort. For example, what you last studied and when you are learning new skills. When you first learn new skills, such as driving a car, you have to put forth effort and attention to encode information about driving. Once you know how to drive, however, you can encode additional information about this skill automatically. Now we have different types of encoding strategies: semantic, visual, and acoustic. Semantic encoding involves the encoding of words and their meanings. It's a most effective form of encoding. Attaching meaning to information makes it easier to recall later. And it involves a deeper level of processing. Visual encoding is quite simply the encoding of images. And that is words that create a mental image, such as car, dog, and book, which are concrete words, are easier to recall than words such as level, truth, and value. Try this as a simple, quick exercise. Try to conjure up an image of a car, or your favorite car, or your dog. Now try to conjure up an image of truth and value. Clearly, you see the difference between concrete and abstract. The third encoding strategy is acoustic, and that is the encoding of sounds. And, by the way, there is also an interesting phenomenon called the self-reference effect. This is the tendency for an individual to have better memory for information that relates to oneself in comparison to material that has less personal relevance. More on that a little bit later. One of the earlier models to be put forth with regard to memory is that advanced by Baddeley and Hitch. They proposed a model of storage where short-term memory has different forms depending on the type of information received. For them, storing memories is like opening different files on a computer and adding information. And with regard to short-term systems, they described a visual spatial sketchpad, an episodic buffer, and a phonological loop. This model you will find illustrated in your OpenStax textbook. According to the model, a central executive supervises the flow of information between the systems. Another early model that was advanced is called the Atkinson-Shiffrin modal of memory model. Information passes through 3 distinct stages in order for it to be stored in long-term memory, and is based on the belief that memories are processed the same way that a computer processes information. Now, this also is illustrated in Chapter 8 of OpenStax, and what is essentially described is a 4-stage model, one beginning with sensory input, leading to sensory memory, then to short-term memory, and then to long-term memory, each one having distinct, separate characteristics. Sensory memory is the storage of brief sensory events, such as sights, sounds, and tastes. And they are stored only up to a couple of seconds. It is the first step of processing stimuli from the environment. If the information is not important, it is discarded. If the information is valuable, then it moves into our short-term memory. Short-term memory and working memory is a temporary storage system that processes incoming sensory memory, and it lasts about 20 seconds, which is surprising to many students because it seems to be almost interminable. And research has shown that it has a capacity of about 7 items plus or minus 2. And this is largely based on Miller's seminal paper, Magic Number 7 plus or minus 2, done quite a number of years ago. Short-term memories are either discarded or stored in long-term memory. Now, there is something called memory consolidation, and it involves the transfer of short-term memory to long-term memory. One way memory consolidation can be achieved is through rehearsal. What is that? Well, you kind of know what that is. It is the conscious repetition of information to be remembered. I'm sure you've been in circumstances where you needed to remember someone's telephone number and you didn't have a piece of paper to write it down onto, or perhaps your phone wasn't immediately available and you could just enter it in as an electronic note. What you found yourself doing is repeating the numbers to yourself over and over and over until you can access something and write it down. Also, you can just simply keep repeating it, and it will eventually make its way into long-term memory. Well, what is long-term memory? Long-term memory is the continuous storage of information. It has no limit and is like the information you store on the hard drive of a computer. And there are 2 components of long-term memory, explicit and implicit. And the entire long-term memory model is illustrated in your OpenStax textbook. So take a good look at that. It basically describes long-term memory as an explicit and an implicit process. And then explicit memory can be further broken down into episodic and semantic, and the implicit memory can be broken down to procedural and emotional conditioning. More on that a little bit later. With regard to explicit memory, again sometimes called declarative, and the reason why we call it declarative is because you can declare what that memory is. I remember this, I remember that. It is essentially memories of facts and events we can consciously remember and recall. Explicit memories include 2 types. One is semantic, and these are knowledge about words, concepts, and language. For example, stop for a moment and answer my question, who is the Vice President of the United States? Well, if you were correct in your recall for that, you used your semantic memory to retrieve that information. I think everyone knows who the President of the United States is, relatively easy. But the relative ease of using semantic memory doesn't belie the fact that it is still very, very an effortful process, as we will learn a little bit later. The other type of explicit memory is episodic, and this is information about events we have personally experienced. For example, remembering your 5th birthday party. The what, where, when of an event. For example, what were you doing yesterday afternoon at about 12 p.m.? It is also called autobiographical memory. And incidentally, a very small number of people have a highly superior autobiographical memory known as hyperthymesia. Now, we also have an implicit memory system. These are memories that are not part of our consciousness. They are formed through behaviors. And there are 2 types of that. One is procedural memory, and that stores information about how to do things. Many of you know how to ride a bike. And if you think back about when you learned to ride a bike, you probably recall certain specific events that surround that. That would be an autobiographical memory. But the fact that you did acquire the skill of riding the bike is not one that arises from autobiographical memories, but from the sheer repetition of the skill that went into that action. But I ask you now, and this is what makes it easy to distinguish procedural memory from the other memory systems, and in particular the explicit memory system. If you could write down on a piece of paper the steps that are involved in riding a bicycle, could you pass that set of instructions to another person such that they would read it and then be able to get on the bicycle and ride away? Of course not. That seems absurd, because you probably remember that in acquiring that skill, it required repetition. Other examples of it are tying your shoelace and driving a car, many of you which will soon approach that exciting opportunity, as well as an anxiety-provoking opportunity vis-a-vis your parents' feelings about that. Implicit memory also includes behaviors learned through emotional conditioning. For example, you might have the fear of spiders, but not consciously remember why or what occurred to conditioning that fear. Now, how do you get information back out of storage? Well, that, as I alluded to earlier, is called retrieval. It's the act of getting information out of memory storage and back into conscious awareness. Retrieval is needed for everyday functioning. For example, knowing how to drive to work or how to perform your job once you get there. And cognitive psychologists have discovered 3 ways to retrieve information. And they are recall, recognition, and relearning. In recall, being able to access information without cues is very, very important. And recall is frequently used for an essay test, which, fortunate for you guys, is something not done here. Another way of retrieving information is being able to identify information that you have previously learned after encountering it again. We call that recognition retrieval. And guess what? The multiple choice test questions that you are presented with taps into the recognition aspect of your memory, because you have previously learned it, presumably, and you are encountering it again. I find multiple choice questions to be equally effective in testing a student's knowledge base. I find it to be as effective as recall, even though many students erroneously believe that recognition tests, such as multiple choice tests, are easier than recall tests, such as essay tests. But that's the way it is. Anyway, the third form of retrieval is learning information that you previously learned. After you learn Spanish in high school, you might forget how to speak if you do not use it. However, if you try to relearn it, you will learn it quicker than the first time. Which brings up an interesting point, which is why I recommend that you read sections of the text, listen to these lectures, because everything that I am saying to you in this lecture reinforces the material that's in the textbook. If you read the textbook, then listen to this lecture, then you'll see exactly what I mean. This is all part of trying to facilitate the relearning process for you. You learn it in your first pass by reading the textbook, you reinforce it by listening to my lectures, and you repeat. Now, there are various parts of the brain that are involved in memory, and while I'll allude to some brain structures here, we're going to be able to expand on some of them in the next section, which is biological psychology. But there are some neuroscientists who are noted for some of their earlier work on trying to study memory. One individual by the name of Carl Lashley, also described in your textbook, he was looking for evidence of a memory engram. That is, a group of neurons that serve as the physical representation of memory. What Carl Lashley did was study parts of the brain involved in memory by making lesions, also called ablation, in the brains of animals such as rats and monkeys. Lashley trained rats to learn their way around a maze and then made lesions to try to remove that memory. Lashley was unable to find evidence of an engram. The rats were still able to remember their way around the maze, so he formulated a new hypothesis. He called that equipotentiality hypothesis. And what that means simply, if part of one area of the brain involved in memory is damaged, another part of the same area can take over that memory function. We see this frequently in the cases of stroke. More on that later. Another significant researcher was someone by the name of Eric Kandel, and he studied the synapse and its role in controlling the flow of information through neural circuits needed to store memories. As an aside, a synapse is the space between two neurons. More on that when we get to the topic of biological psychology. And just in summary, some of the parts of the brain that are involved, we now know is involved in memory, is the prefrontal cortex. That's in the front part right over here. And there's also the cerebellum. That's in the back part of your head below the occipital lobe. More on that later. And the amygdala and the hippocampus. You probably recall me making reference to the amygdala and the hippocampus, but more on that later. Just a brief summary. The amygdala, which is involved in fear and fear memories, processes emotional information, and it's important in encoding memories at a deeper level and memory consolidation. The hippocampus is associated with explicit memory, recognition memory, and spatial memory. It projects information to cortical regions that give memories meaning and connect them with other memories. And it's also involved in memory consolidation. Damage to the hippocampus leads to an inability to process new declarative memories. And this gives, I suppose at this point, rise to the discussion of a famous patient. We refer to him as patient HM. In clinical investigations, whenever patients participate in studies, we never refer to them by their full names. We want to protect their privacy, so we typically use their initials. By the way, patient HM died within the past 10 years, but not before providing decades and decades of valuable information with regard, in particular with regard to the role of the hippocampus and some other memory structures in long-term memory retrieval. Patient HM had temporal lobe seizures, and it also involved the hippocampi. And the sections of the temporal lobe and both hippocampi were removed to control the seizures, and they were found to be very, very effective. But the consequence of that was that the declarative memory in patient HM was seriously effective. He could not form new memories. And in particular, he could not form new semantic knowledge or episodic memories. But incidentally, he was still able to form implicit memories. The cerebellum, which I alluded to earlier, plays a role in processing procedural memories, such as how to play the piano and classical conditioning. You all remember that exercise that we did in class, right, and my slapping of the hand, yada, yada, yada. And it is the cerebellum that, in part, contributes to the fact that conditioning can take place. Damage to that part of the brain prevents classical conditioning, such as an eye blink in response to a puff of air. Damage to the cerebellum could also interfere with other types of memory that had been acquired implicitly. Yes, you could damage the cerebellum and lose the ability to ride a bike. The prefrontal cortex, as I alluded to earlier too, which is in the front part of the brain, and we're going to get back to that later, that is through biological psychology. The prefrontal cortex appears to be involved in remembering semantic tasks. PET scans show activation in the left inferior prefrontal cortex when completing semantic tasks. PET scans are positron emission tomography. This is a particular technique that is used to identify particular areas of the brain when they are involved in various psychological processes such as memory, and in particular remembering semantic tasks. And retrieval of information is also something that very, very important with regard to this. Now, we need to mention neurotransmitters at this particular point, and we're going to get back to that a little bit later. Communication among neurons via neurotransmitters is critical for developing new memories, and some of which arises from something called repeated neuron activity. Increased neurotransmitter in the synapse, stronger synaptic connections. This is how memory consolidation occurs. But I'm going to hold off on that material because we're going to revisit the whole issues regarding neurotransmitters a little bit later. Now, we also have a phenomenon called flashbulb memory, which perhaps you have heard of it. This is a record of an atypical and unusual event that has very strong emotional associations. For example, most people can remember where they were when they first heard about the 9/11 terrorist attack. Professor J remembers exactly where he was and what time of the day it was when President John F. Kennedy was assassinated on November 22nd, 1963. By the way, I was 8 years of age, and I was sitting in my second grade classroom. Mrs. Sellery was the teacher, who then broke out crying when we learned that the president had been killed. Anyway, I am going to stop at this particular point to give you a little bit of a break from my lecturing. And I'm going to encourage you to continue reading the balance of the chapters. Areas in there are amnesia, anterograde amnesia, retrograde amnesia, and constructive processes, reconstructions. Please continue to read the entire chapter and get back to me if you have any questions. Right around the curve is our first exam. And as I described earlier, it's 33 multiple choice questions, and with equal representation among the 4 chapters that you will be responsible for, and that is learning, memory, and biological psychology and development. Hope everyone is safe and healthy and hopefully not too bored. We're all going to get on the other side of this, and everyone is going to do just fine in this class. Just keep it up, guys. Hang in there, and toodles for now.